3D transformations. Operations performed on 3D objects. Previously we have seen 2D transformation. 2D transformation, we have been performed all the operations in the two-dimensional plane. Two-dimensional. One is x-axis, another one is y-axis. Here we are going to add the third dimension, that is z-axis. So that here we are going to do all the transformation operations, so that which is called 3D transformation. Here also we have the same 5 operations. See here, one is translation, another one is scaling, rotation, reflection, shearing. So these 5 operations here also we are going to perform. So already we have studied what is translation, moving the object from one place to another place, that is changing the position. Then for that, in the two-dimensional plane we have been used only 2 parameter, tx, ty, but here 3 dimensions, so that we have been added one more parameter, that is tz, tx, ty, tz, 3 parameter we must record for translation here. Next we see the scaling, that is changing the size, either maximize or minimize, increased or decreased manner. This is what called scaling. Here also we record one more parameter, that is sx, sy, sz. 3 parameters, scaling factors we must record. Next, rotating with the theta, or rotating with some angle, that is here the rotation, 3 type of rotation, based on x-axis, y-axis and z-axis. So 3 type of rotations here we are going to see. Next, reflection, it is a mirrored image or rotate 180 degree of given object. Here also we are going to see 3 different type of reflection, that is xy plane, yz plane and zx plane. We cannot change the order, xy, then yz, then zx. So in that manner only we have to write. Okay. Next is shearing, that is skewing or tilting or distorting an image is called shearing. Here also we are going to see 3 type of shear, that is x shear, y shear, z shear. So 3D translation, moving in a 3D object from one position to another position. See here the formula, as we have written the two-dimensional translation, x dash is equal to x plus tx, y dash is equal to y plus ty, z dash is equal to z plus tz. Okay, let's we write in the matrix form for translation, and for this translation we know we must record 3 transition parameter, that is tx, ty, tz. These 3 transition parameter record. Using this we are going to write this matrix form. So x dash, y dash, z dash, which is equal to tx, ty, tz plus xy, z. So previously we have seen what is homogeneous coordinate, that is we have to represent matrix in multiplication form. For that we have to add one more dimension along with that. When we implement in 2 dimension, we have added one more dimension for homogeneous coordinate, that is 3 cross 3. Here we are working for 3 cross 3 matrix, so we have to add one more direction, that is 4 cross 4. So here see here, this is also we have represented the matrix multiplication form. So x dash, y dash, z dash, homogeneous variable, which is equal to, we have to write the diagonal matrix for this. So here, see here, this is an identity matrix we have written as it is. Then either we can represent in the tx, ty in the row wise or column wise, whichever we feel convenient we can write. Here I have written the column wise, so column wise. Now this is the old parameter x, y, z. one homogeneous coordinate value. Here we have represented 3D translation in homogeneous coordinate form. Next, let's we see the 3D scaling. 3D scaling, changing the size of an object. So it requires, it is also requires 3 parameter Sx, Sy, Sz. Here also initial coordinate, final coordinates are available. Initial coordinate we say it as a P of x, y, z, and the final coordinate we called it as a x dash, y dash, z dash. Let's we derive a formula, that is x dash, x dot sx, y dash is equal to y dot sy, z dash is equal to z dot sy. When we convert it into the matrix form, x dash, y dash, z dash, which is equal to sx, sy, sz into x, y, z. This is the 3 cross 3 matrix for 3D scaling. When we represent in the homogeneous coordinate form, we have to add one more dimension, so that we have written as it is the previous 3 cross 3 matrix along with the one more dimension. So we have added x, y, z along with one dimension.